start the afternoon session now.
Yeah.
And Professor Shirish Pathare will give the first.
Okay, thank you. Okay, so good afternoon, or maybe good night, sweet dreams. Okay, so anything, feel free to sleep, absolutely no compulsion. Okay, so if you wake up and get few things, that will be really grateful to you, because something that I'm going to discuss for next 2 hours will be something that we will follow during the labs, right? And when we say physics lab, right, we all have been doing physics lab, right? Since when? Maybe your schools, right? You entered physics lab first time in the school, right? Then +2 levels, and now first year, and maybe still continuing with it, right? So there is nothing that I will be teaching you, right? I mean, you have been doing that. What grade I'm going to talk about, right? But we'll discuss certain aspects that we are supposed to know, right? When we enter a lab. Fine. So what it means to study experimental physics at the undergraduate level, okay? Because there are different levels. At school level, you are introduced to certain demonstrations. We do experiments, but I'm not sure whether we all do experiments, right? What is the difference between demonstration and an experiment? Please bear with me. I'll be asking you some questions, so please. But you can also show the demonstration. That also I can perform an experiment here and keep looking at me here. Is it? Okay, fine. Sit straight, everybody. Keep your pens down, right? Keep your pens down. Your legs 90 degree. 90 degree. No cheating, right? No cheating. Legs 90 degree, hands like this. Yeah. And you're not going to bend forward. You're not going to move your legs. You know what's going to happen? Try getting up. They are not listening to me. Okay, come on. Okay, down. Okay, so this is a simple CG, right? We have our CG here, maybe 4 points below your navel point, right? So when you say that you want to stand, you have to either get your CG in line with your point of contact. That you can do only by moving your legs or maybe bending forward, right? Just a small demo. Of course, you did not know. So not every time you know what is the outcome of demo, right? Just to wrap up, demonstration is most of the time qualitative, right? You don't collect the data, you don't do analysis, you don't plot any graph, nothing happens in that. Some phenomena shown to you, okay, in a qualitative way. Whereas in experiment, you engage yourself with all those factors of data collection, right? Analyze the data. Then how many of you calculate uncertainty or error, as we call? There are few. Nice to see that, right? Good. Then you interpret the data, write a report of your experiment, and use your time effectively, right? What do you mean use your time effectively? You finish everything in the given time, right? Rough journal is complete. Go home, write the fair journal, get the signature. Great. Situation is that good, right? Every day in the lab, you finish everything in time? No. So say no, right? You don't need to agree with me. This is not a place that you should agree with me. Okay, I'll be happy if you disagree. Okay, fine. So, if this is the thing that we are going to, we have been doing for so many years, what is it remaining now to discuss? Right? Question, right? You do question people when you were given vernier calipers to measure diameter of the bulb in simple pendulum experiment? No, you just accepted, diya hai bhai, Bhagwan ka diya hua hai vernier caliper, right? When did you ask them why vernier caliper, why not just a scale, why not a screw gauge, right? More accurate. Just reserve this question We'll discuss on this. Okay, these words more accurate, right? Okay. I mean, if I forget, just remind me. Okay, maybe it may happen that even I may sleep, right? So just remind me. Did you question your teachers when you are asked to measure period for 20 oscillations? Why 20? Why? It has become less. Great. Then why didn't you go for 50? Time nahi utna. Come on. Come on. Just, if you have, I mean, some of you have laptops in front of you, right? You who open a spreadsheet, let's calculate, or maybe you can write it somewhere. Suppose you take 100 oscillations. Suppose you take 100 oscillations, right? You have to take it 3 times, T1, T2, T3. God knows why they ask you to do it 3 times, right? But you do it 3 times, T1, T2, T3, 100, 100, 100, right? 100 oscillations, right? So maybe, let's say 100 seconds, fine. Let's say 100 seconds for some length, you get 100. So 100, 100, 300 seconds, right? For one length, agree? You are expected to take at least 5 lengths, right? So 300, 300, 300, 300, 300. How much time? 1500 seconds. How many minutes? Do it fast, come on. 12:25. Can someone give me a good answer? 25? Okay. So you are finishing your data in 25 minutes, right? Just taking the data. Then maybe you need some time to adjust the length, right? 10 more minutes for that, maybe 2 minutes for adjusting things, right? 35 minutes, right? Then we also have to do some time pass. No. So another 20 minutes, you have 2 hours, right? 2 graphs, great. How much time do you take to plot a single graph? 10 minutes, 15 minutes? 15 minutes. You all are good students, right? So 15 minutes, right? So 2 graphs, half an hour. We have to reach 2 hours, come on. Okay, so the idea is not just, that you take more number of oscillations and then you achieve really something great accuracy. We will try to discuss that also, right? Did you question when you are asked to plot a specific graph to verify maybe inverse square law? Inverse square law you all know? Oh, great. So you have a bulb and you have some kind of a sensor and you move it in steps, right? And then finally you plot a graph of I versus 1 by d square. Have you done this experiment? How many of you have done this experiment? And how many of you are happy with the nature of the graph? No. There is a problem. The moment you plot this graph, you will land up in trouble. You will not get a beautiful straight line graph. Can someone tell me why that problem is there? We'll discuss that. Okay. Again, somebody who raised their hand, just remind me. Okay, when we discuss something on the graphs. Okay. When you got repeat mark, okay, when your value was 11, right, instead of 9.8, did you argue with your teachers? No, this is right, because the uncertainty that I have calculated is plus minus 2, and your 9.8 lies in that range. So my experiment is okay. I should not repeat it. Right? So there are so many things. The moment you enter a lab, getting an apparatus in your hand till you leave the lab, right? The question why is very important, right? And this is what we are going to discuss now. So this is the outline for these 2 sessions. Hopefully, I will be able to finish the slide. The number of slides is 121. Not so ambitious to finish things. You can see the slide number here. So when you reach 120, you can say, next slide is thank you. That's all. Okay. Okay. So there's one slide thank you and one title slide. So now only 119 slides. Okay. Okay. So let's start with procedural understanding. What do you mean by this term, procedural understanding? It is the decisions that have to be made for doing laboratory work, right? Every single decision. I will give you certain examples of that. First, so you have to measure a voltage and it is measured using an analog voltmeter. Analog, pointer wala. You all know this, right? Okay, fine. 0 to 2 volt is the range of this. So where the reading shown by the pointer moving over dial is reading is constant, right? Okay. Then the same voltage is measured by a digital voltmeter, same range, 2 volt range. and in the last digit is found to fluctuate. It change हो रहा है, it's fluctuating. Right? Which meter should one prefer, analog or digital? You have to think, wait. There's a way in which we will take a vote, right? It's just that when I ask you a certain question and want you to vote, okay, nothing technical, you just have to close your eyes, right, and raise your hand, okay, so that you don't know who is that person who is agreeing with you, right? Okay, fine. So only two options, analog and digital. Think about it. I'll give you 5 seconds to think. Done? Okay, close your eyes. Close your eyes. It's such a nice chance to sleep. Come on, make good use of it. Okay, close your eyes, all of you. No cheating. Okay. Analog, raise your hands properly. Okay, down. Digital, please raise your hands. Okay, down. Open your eyes. Most of you raise your hands for digital. Can someone tell me why digital? क्योंकि analog पुराना हो गया. Somebody said less error. The range is same. The least count is same. Can you elaborate more on that? Yes. Okay, for analog, she is saying that parallax error is there, but there is a way to do that. There is a term called mistake, and then there is a term called error. This is a mistake, right? If you don't look at it properly, that's your problem, not my problem, right? So I'm talking from the point of view of a good student who is taking care of this parallax problem and all, and looking into that analog quite well. Okay. Very good. Very nice. Very nice. Did you hear what she said? Digital will sense the worst case scenario. What do you mean by that? Why the hell am I doing this measurement? Right? If my device can show me that there is some kind of a variation happening in my circuit, instead of hiding it, that is the whole purpose. That variation, that fluctuation might be due to different reasons. Suppose if I am measuring 18.12, that is the volt, right, range. That 2 is fluctuating. It is possible that the reading is between 18.11 and 18.13 or 18.12 and 18.13. So it's fluctuating. Possible. One reason. Second is something is loose, fluctuating. So instead of hiding, I need to know what's the problem, right? So if my device can tell me what is the worst case scenario, as she said, great, I will prefer digital, right? So most of you raise your hands for digital. Yes, good, but this is the actual region. Okay? You really need to know what is the problem in your device or circuit, okay? And that digital will show it better, right? Okay. Have you seen such kind of a tube, a plastic tube? Maybe you use it for AquaGuard or whatever devices that you have in the lab, right? You have to measure length of this tube. How will you measure? Okay, using a thread. Do you find a problem in that? Who said? Okay, using the thread. Do you really think of some problem with that? See, the moment you have a thread, you have to align that thread along the length of that pipe, every single point of it, right? It cannot be loose. So you are actually adding, more to your worries. Not a very complicated problem. I'm just giving you a scale. Right? You have a scale on your table, a 1 meter scale, right? You just have to put the tube and measure the length. Easy, right? Why are you so tensed? What do you mean by won't give us accurate answer? You are correct, but what do you mean by that? Okay, so will it remain curved every time? Will you be so, अरे बे वो curved है मैं क्या करूँ उसका अभी? No, you will do something. What will you do? You will thread. You will try to make it straight, right? While doing that, what will happen? Exactly, right? So sometimes you might overstretch it, right? So you might overestimate something, right? Then you realize, oh no, I have made a mistake. I have overstretched it. Okay. Then thoda sa nahi theek se pakad raha, main theek se pakad raha hu. You might underestimate. How will you come up with the solution? Simple. Do it multiple times. Okay. Statistics will help you. Right? Answers are very simple. Okay. Very simple. Okay. Inner diameter. 1 year caliper. Great. Traveling microscope. Very good. Any problem with 1 year caliper? It is the best, yeah. But now, suppose I give you 1 year caliper and this tube. Yeah. Okay, fine. So, do you find any problem with that? You will be using your upper jaws, right? Upper jaws to measure it, right? So, what will happen? Sometimes you might overstretch, sometimes you might loosen it, okay? So, again, do it multiple times, right? That is one. Second, indirect way. Fill it with water, empty that, okay, but then you are still in trouble because there will be some droplets. Yeah, okay. So of course, the moment you think of any measurement, you have to also think about what can be the problems arising in those measurements and take care of that, right? That's procedural understanding. You have to understand your procedure to the depth. Okay. Now, I'll be showing you this circuit for IV characteristics of PN junction diode, right? I think you all must have done this, right, in some point of time. So you have to spot the correct circuit. Again, I will give you 4 options, right? You don't have to discuss this with anybody else, right? It has to be your answer. And once you are done with it, I will ask you to close your eyes again. So these are your 4 options. You have 10 seconds. Fine. I give you 20 seconds, but fine. Are you done? Chosen your option? Can we take a vote? All of you ready? Okay, close your eyes. All of you, please close your eyes. Yeah. Option A, raise your hands. Okay. Option B, properly. Please raise your hands properly. Okay. Down. Option C. Okay, down. Option D. Okay, down. Open your eyes. Any other option? None of them is correct. I think your teachers have been yelling at you. Voltmeter has to be parallel. Current meter has to be series. But you still chose something. Okay. What is the moral of the story? Don't believe me. Right? Okay. So I won't let you sleep. Okay. So let's see who sleeps first, you or me. Okay. So these are some kind of questions which actually test your confidence, whether you can be very sure कि नहीं एक है ना वोल्टमीटर पैरेलल चल जाएगा वो करंट मीटर को भूल जाते हैं that's not the thing. You have to be to the point. Voltmeter will have to be parallel and ammeter will have to be in series, right? No compromise in that. Okay, fine. So let's jump on to the next. The process of solving an experimental problem. Okay, what is the ideal process to do that? By the way, I'll be, I think, sharing this slideshow with you all. So you don't have to, I mean, if you want, you can write it down, but there's no compulsion on this. Okay, you will be getting this slideshow as it is. If at all, when you go back, you want to use this slideshow, present it in front of your fellow friends, feel free to do that. Remove my name, put your name, perfectly fine. I have no problem. I'll be happy if you do that. I'm not removing my name, but fine. Okay. Okay. So you understand the objective. The moment the paper comes in front of you, understand the objective. What are you supposed to do in this, right? So for example, simple pendulum, right? Your objective is to find G, right? You have to find G. Then look for relevant equations in theory based on what is asked in the objective, right? So then you will search, is there any theory given to you? Okay, T is equal to 2 pi root of L by G is something, somewhere it's written, right? So you have got that. Then you linearize that equation to decide which graph to plot. Okay. Do you know what a linearization means? How many of you don't know? Raise your hand. Okay, next slide will be on that. I will explain you that. Then once you know which graph to plot, then you spot the relevant variables for measurement. Because now you know this is y-axis, this is x-axis. This is what I have to measure, right? Then you choose your instruments. Because now you know, I mean, what is to be measured. Then you will choose the instruments. Then you start collecting the data, analyze, maybe use graph plotting. Okay. Then uncertainty analysis, which I think you said you have been doing that, great. And then represent the final answer with proper significant digits. And this is where your uncertainty analysis comes into play. Okay, if you get something like 9.758924, what should be your final answer that you should be writing? That depends on what is the significant figures in your uncertainty, right? Okay. So let's start with linearization. Very simple, right? You square both the sides, right? Then do some jugglery with the variables and then compare it with y equal to mx plus c, right? So your y is nothing but t square and your x is nothing but L and m is your slope, right? And c is, I know c is constant, but here 0, okay, fine. So this is the graph you should be getting. You just said that it should pass through origin, right? Is it compulsory that it should pass through origin because the equation is telling you? Yes, right. There can be nothing going wrong in your life that it will not, allow it to pass through origin according to equation. So I will do the experiment according to equation. So my line will have to pass through origin, come what may, my points are lying wherever. Is that the thing? Exactly, best fit. So you should not bother about origin at all. My question is it possible to get this kind of a graph? How many of you say yes? Raise your hands. Don't believe me, I'm telling you again. How many of you say no? Raise your hands. Okay. There are people. Good. You are taking me seriously now. Okay. Very good. Now, you are measuring length, right? You are measuring length. What do you use to measure length? Don't tell me vernier caliper. Scale. A wooden scale? A newly bought wooden scale from the market? I mean, is it like brand new wooden scale that you get? No. It's the old one, whose zero is just not visible. First 2 or 3 mm are gone. Right? You use measuring tape, but fine. Let's start with, wooden scale. Okay. So now if those first 3 mm are gone, and you don't bother about that, what you bother about is what is the length of that on this other end. क्योंकि इसने बताया नहीं वो खराब है. What will happen to every point? It will be shifted by those 3 mm. So my line will not pass through origin. But if somebody comes and tells you, "Arey, come on, look at that. I mean, it's not passing. I mean, there is no zero there on the scale. It's starting with 3 mm. You made a mistake. So you add 3 mm in that. And then it will pass through origin. Right? Now this is a systematic shift. Systematic shift. Okay, in other words, what you call as systematic error, which will shift whole your graph. Will the slope change? There was one question in your written test. Remember? There are 2 students who are doing the simple pendulum experiment, right? One student forgot to add something, okay? Will that G value be same? And now we are saying no. G value be same. Why? Because the slope is not changing and I'm getting my G from the slope. Okay, so the whole graph is shifted systematically and my slope is not going to change, right? Okay. Okay, so now you have this equation. I don't have to explain you this equation. I mean, you will kill me. S equal to ut plus half gt square. You have to find g from this equation. Let me explain you what is the experiment. Right. Okay, so this is the experiment. So you have a steel ball. You are dropping this steel ball. It's a free fall, right? And you have two photo gates. How many of you know what a photo gate is? So there are many who do not know what a photo gate is, right? Okay. Have you heard of burglar alarm? Right, I mean some thief passes through that and then there is an alarm going on, right? Okay, so what is it? So you have a transmitter, you have a receiver, right? So if that flow gets broken, there will be some pulse created in the subsequent circuit and that will switch on the burglar alarm. This is like a burglar alarm. So photo gate 1, if the ball passes through that photo gate 1, okay, there will be a pulse created and it will start the stopwatch. And then the second photo gate here, it will stop the stopwatch. Are you getting it? Yeah, photo gate 1, photo gate 2. Now the way in which I am doing this experiment is every time the distance between the dropping position of steel ball and photo gate 1 is constant. I am not changing that. What I am changing is position of photo gate 2. So from here, then here, then here, then here, then here, and then here. So suppose I have got now S1 T1, S2 T2, S3 T3, S4 T4, S5 T5. 5 data points to plot a straight line graph. Right? Which graph will I plot to get G, either from slope or from intercept? You have your notebook in front of you, just work it out and tell me what should be on the y-axis and what should be on the x-axis to get G, either from slope or from intercept, whichever, whatever that makes you happy. Wait. Do you have a doubt or your answer? Wait. Let them also work it out. Done? How many of you still need some time? Raise your hands immediately. Okay. Okay, can we discuss now? Can we discuss? Yes or no? Are you sleeping? No. Okay. Maybe 10 seconds more and then we'll discuss. Okay. Let me have some answers from you. Yeah? Sorry, S? 2S. Okay, by T. Okay, that is one answer. Any other answer? S versus 1 by T. S versus 1 by T. Are you making some mistake? I think you should be getting the same answer as she said. Okay. Okay, she's saying 2s versus t square. That is another answer that she is giving. I'm not saying whether you are correct or wrong. I'm just gathering the answers. S by t and t by 2. Okay. Okay. Any other answer? A bit louder. T square versus s. Okay, t square versus s. Any other? Okay, those who have given me the answer like s versus t square, just look at the equation very carefully. You still have t remaining here. Now, if you are telling me that u is going to be 0, that's not the right thing. Where will u be 0? At this point. But where the time measurement is starting? Here. So, you will be finite, constant, but not 0. Right? So, these are the three things. Right? S by t versus t, then s by t square versus 1 by t. And if you still want to show off, maybe third one. I mean, of course, that is not needed, but you can do jugglery of variables and get as many combinations as possible. But we normally trying to go with the simplest one. Right? So, always make sure that this constant c in y equal to mx plus c should not have any variable term. Right? Okay. Fine. That is linearization. Okay. Now the next one, let me scare you more. This is another experiment in which a student observes the variation of current in a wire which is in contact with a thermal reservoir. So that is at constant temperature. So the expression for current is given by I is equal to V by R0 into 2 upon 1 plus root of this quantity, right? So the data that you have is I and V. Okay, so student collects the data of I and V. The value of R0 is given to you, then alpha is given to you. You have to find out beta, right? Just write down this equation. And then you have to tell me which graph will you plot to get beta. I'll give you a minute to do that. In fact, you don't have to even write it down. You can just look at the equation for maybe 10 seconds and you should figure it out. It just maybe 2 or 3 steps answer, the first answer. For the second answer, you have to maybe expand it a bit and then do some jugglery and then come up with it. That will take some more time. But the first answer, you should be, able to do it maybe within no time. Okay, any answer? A quick answer. Of course, it takes some time to look at the equation and take some variables on left side, right side, and then maybe come up with certain answer. But it's a good habit to do that. Just look at the equation. You don't have to always use your pen and paper. But shall I tell you the answer, or you want to give the answer? No. Okay. Can we discuss? You want time? You need time? Yes or no? Okay, can we? Let me show you the quick answer first. Yeah. So you have this equation. Okay. Do it like take this R0 on this side, ulta karke, right? Take 1 on the other side. That's your answer. A quick way of doing that, right? So you can plot a graph of this quantity versus V square, right? But now if you still want to, simplify your calculations further in terms of the data calculation, I'm saying, right? You can just expand it and finally you get this V by I versus Vi. That will just save you from certain calculations, that's all. But this was the quickest one. Nothing, you don't have to expand anything, you don't have to combine anything, nothing. So this is the process of linearization. Just look at the equation and that tells you which graph to plot. And it's a good practice to do because as far as your curriculum experiments are concerned, things are already there for you, which graph is to be plotted. Right? But when you encounter a new situation, when you go to your master's or maybe further or go for an internship somewhere, and then you have no clue, how to handle that equation, this skill actually helps you a lot. Right? Look at the equation, see what graph can you plot. Okay, and most of the time linear graphs save your life. Getting answers from linear graph slope and intercept save your life. Right. Then spot the relevant variables for measurement. Right. So in an experiment you may come across many variables, but what you do, you focus your attention only on 2 variables. What do I mean by this? Suppose you are the person who invented simple pendulum. Right? You are the inventor. What all variables can you think of? Don't tell me length and time. I mean, that we all know. Will you just keep quiet? हाँ नहीं length और time देख के हाँ बहुत हो गया. Sorry? Okay. Okay. Amplitude, then altitude. Oh, okay. What else? Yeah, so amplitude or angle. Yeah, right. Anything else? Shape. Right. So you might like to change so many things. But after doing all those things, then you will realize that no, I mean length and time are the sum, these two quantities which I can actually play around in my lab setting, right? In this, not different altitudes, but just here, right? And things will be still fine. But of course, there are research papers with large amplitude pendulum, and you can do many things with that. It's just that you cannot do it just with your normal stopwatch. Right? There is a reason for that. If you go from 10 degree to maybe 20 degree or maybe 30 degree or 40 degree or 50 degree, okay, and you release that bob from 50 degree, you won't be able to find out the period of oscillation when the bob moves so fast and comes back. Right? We have certain limitations. We can't do that. Right? So with all those possible limitations in our lab settings, these are the only 2 variables, L and T. Is that clear? Yeah. Okay. So of course, independent variable is L and dependent is T. Why not the other way around? You can do it other way around. Why not? Yeah, it's stupid. Yeah, exactly. It's stupid, right? For 1 second, kitna length aega? 1.2 ke liye kitna? I mean, it's so stupid. Instead, I mean, just change the length and measuring time is so convenient, right? That just tells you which is your independent and which is your dependent variable. Okay. Now you have a situation here. So you have a measuring cylinder, right? And then there is a hole, or maybe there is some kind of a tube there, and then the water is coming out from that tube. Okay? And I have given you a stopwatch. These are the 2 variables, time and volume. Which is your independent variable and which is your dependent variable? There are only 2 options, right? If time is independent, what does that mean? That after maybe half a minute, what is the flow? After 1 minute, what is the flow? Right? That way. And other way around, if volume is independent variable, you can see what is it. So out of these 2, how many of you feel first option, time is independent and volume is dependent? Raise your hands. Don't have to close now. So come on. You don't have to look here and there. I mean, that's why I used to tell you to close your eyes, but that's fine. Properly. ये अपने पास shoulder है, right? Okay, fine. Okay, time is independent, volume is dependent. And what about the other option? Volume independent and time dependent. How many of you? Okay, majority is saying that. Why do you say that? Volume independent and time independent? Because this is what we normally do, ना? इतने टाइम के बाद कितना वॉल्यूम है, इतने टाइम के बाद कितना वॉल्यूम है. So, those who raise hands for second option, you want to convert to again first option? No. You are sure second option? Confused? Have you been successful in confusing you sufficiently? Oh, good. Thanks a lot. Okay. So, time, let me just explain you. Time as independent variable and volume as dependent variable. Do you find a problem in this? Those who answered volume as independent and time as dependent, do you find problem with their answer? Time as independent and volume as dependent? Yes, so? That's the nature I need to study. That's the whole experiment. You know this experiment, Poiseuille's method? That's what we are supposed to get that, I mean, that curve. But while doing that, taking time as independent and volume as dependent, let me tell you what the problem is. Right? There are markings on the measuring cylinder. What do you mean by human error? Okay. I will come to this point, not now. Do you really think delay will matter? पानी इतना fast नहीं जा रहा है, right? Water is going pretty slow. Okay, so are you aware of 1000 liter? I mean, sorry, 1000 ml measuring cylinder? कितना बड़ा होता है? इतना बड़ा होता है. Its diameter is around maybe 7 centimeter. Pretty big. Right? So any change in that level, and then there is a capillary tube there. There is a capillary tube, okay, because you don't want turbulent flow there. So things are going very slowly. आराम से जा रहा है. Right? So from that, even that smallest division, you just keep waiting कब आएगा नीचे. No, it's very slow. Very slow. So this delay thing does not actually, come into picture in this. The problem is, at say maybe 1 minute, you have to take the data, and then the water level is in between those two markings. What will you do? ऊपर लगा लूँ या नीचे का लूँ? Are you getting my point? Right? There are, discrete markings on the cylinder. So I'll be in trouble if the water level is in between those two marks. Right? And because of which, if I take the volume as independent variable, from 1000 to 900, what's the time? From 900 to 800, what's the time? Are you aware of these lap timing settings in the stopwatch? Yeah. So you can always press that, okay, and you can still know what is going on continuously. Right? So from 1000 to 900, 900 to 800, 800 to 700, right? So if that is your, independent variable, your T can be dependent variable. Did you get that? Or you are still confused? No. Okay. Are you feeling sleepy? Sure? Nobody. Such a shame on me.
Can I create some further confusion?
Yes, please do that.
But this is only, I just like to point out that this is true for water or any Newtonian liquid.
Yeah. Okay.
That is kind of also linked to my talk later this during next week. That
Yes.
in the case of say granular matter, this the concept of hydrostatic pressure is
A bit complicated.
very complicated.
Yeah, very, very
Very
complicated.
simplified state
Yeah.
for us. Yeah.
Yeah.
In some conditions.
Right.
Maybe we'll talk about that.
Sure.
Thanks for this example.
Okay, fine. Okay, another example, charging of capacitor. So you have voltage and time. Which is independent, which is dependent? Time is independent and voltage is dependent. No, ulta. Okay, but I just thought that you might ask me a question before answering. Voltmeter कौन सा दे रहे हो? Analog or digital? Right? If it's analog, the same story continues. Right? If it's digital, do whatever that you want. Because both are numbers. Simple. Right? So it just tells you which is your dependent, independent. Don't have to always go by the convention that this is like independent, this is dependent, because when you have your apparatus in front of you, try to look at the apparatus and that will tell you what is to be done. For example, in Ohm's law, you all have done Ohm's law, right? Everybody? Okay. Now, which graph do you plot in Ohm's law? Voltage and current. Current is on? Oh, great. You plot current on x-axis? Y-axis? Okay. Your college manuals tell you that voltage should be on x-axis and current should be on y-axis. Because that's how you do the experiment. You have some variable power supply, you change the voltage, right, and see what is the current in the ammeter, right? So accordingly, according to convention, voltage should be on x-axis, current should be on y-axis, right? But then you take the slope and you have to again do 1 by r. And why to do that headache? Just plot V on y-axis and I on x-axis. You are done with it. Unless examiner comes and tells you, no, what have you done? Right? So the idea here is, whatever that I'm telling you, if you go and start telling the examiner, that person may not like it. Okay? So if it is written in the exam slip, कि I आपको y पे करना है and V आपको x पे करना है, please do it, that will fetch you marks. But you should understand, it just doesn't matter in my life. I need to get value of r. So I can very well plot V on y-axis and I on x-axis. It's just I need to know what is the idea of independent variable and what is the idea of dependent variable. The idea of independent variable is such that you vary that variable in suitable steps, right? Equal intervals. Why equal intervals? So that even without plotting a graph, just from the observation table, you can make out that for this suitable step, whether my dependent variable is also changing in suitable steps or no. Is there any kind of a saturation coming up? Is there any kind of a peak coming up? Right? Is there a minima? That will be known from the observation table itself. If you vary your independent variable in steps. Okay? Because this is like equal interval है, यहाँ पे नहीं आ रहा है, कुछ तो गड़बड़ है. गड़बड़ है और this is the nature of the system. Is that clear? Yeah. That is the definition of independent and dependent variable. Okay. Choice of instruments. So you choose instruments based on these two criteria: ease of measurement, right, and least count of the instrument, right? Ease of measurement. You use vernier caliper to measure the diameter of the bob in simple pendulum, right? Why do you do that? Somebody I think mentioned in the beginning, right, for accuracy. She left to fill the water bottle. Yeah. Nice excuse. Okay, fine. You could have borrowed water from somebody else, but that's fine. No problem. Okay. So you use vernier calipers, right, to measure the diameter of the bob, right? Why? The least count of vernier caliper is 0.01 centimeter. This is something that you have been using in the lab, right? So if that is the least count, suppose L dash is something like maybe 60.0 centimeter. So my pendulum is like just a thread and a bob, no hook in between. If we use kiya, just stick kiya, that's all, no hook, right? Okay. And radius of the bob will be something like 0.56 centimeter, just some number, right? Why second decimal place? Because I have measured it with 0.01 centimeter least count, right? So what is the length of my simple pendulum? Will be L dash plus R will be equal to 60.56 centimeter. right? Yes or no? Oh, you agree? Sorry? Will you add the diameter? Because in simple pendulum, you assume that to be a point mass. But I mean, you just can't get a point mass which will oscillate, right? So you have to go for a bob. And then you assume that it is at the center of that bob, which is like the center of mass of that bob is, right? Because it's like very nicely sphere and all those things, which normally it is not, but we just assume that, right? That's why on the radius. Okay, so all of you agree? The length of the pendulum? हाँ, मैं कहाँ नहीं बोला. Oh, there she comes. No, don't get scared. This is the point that you asked me and I was discussing that and you were not there. Okay, fine. You had coffee or tea? Nothing, only water. What? Okay. So this was the thing. So length of the pendulum, the thread is 60.0 centimeter and the radius of the bob is around 0.56 centimeter, right? As you said, vernier caliper gives you up to 0.01 centimeter, right? It's pretty good, right? But now when I add it, can I write it like this, length of the pendulum? She has some objection, but I will not tell you right now. Can you do that? Is it okay to write length of the simple pendulum as 60.56 centimeter? Just a moment. I'm just pointing to her because she just asked me that question, nothing. Yes or no? Or clueless? I can't hear you. It seems fine. Okay. It seems fine to her. Who is that? Okay. Okay. What does that mean? So what should I write? Maybe you were saying something. So a change in the no. I'm not using the samosa wala thread. I'm using a nice thread. You know, you get inextensible threads also, right? जो उसको पूरी को बांध के आता है वो नहीं. That stretches, right? So not that. A good thread. So that you can neglect very well. I mean, that change in L is not there. Yes. Right? That's what I think you were trying to say. Right. Okay. So the point that I wanted to make, that I should not be returning it like this, but I should be writing it something like 60.6 centimeter. Because the logic is the majority of this part is measured using a least count of 0.1 centimeter. And a very small part is measured with 0.01 centimeter. So I cannot claim the least count of 0.01 centimeter over the entire length. That's not correct, right? Then the question arises, am I stupid enough to use vernier caliper? Why vernier caliper? Just take a scale, bob रखो, यहाँ से देखो, find out. कुछ तो गड़बड़ है ना? A bit of troublesome thing, right? If I give you a thread, wind it over the bob, get 2 pi r. चलेगा? No, there's still some problem with it, right? These are all indirect methods, right? Vernier caliper will directly give you the answer without all those headaches. So it's just the ease of measurement, the first point. Is it clear? It's just the ease of measurement. That least count, even if tomorrow I give you a vernier caliper with 0.001 centimeter least count, are you aware of this? Vernier calipers are available with 0.001 centimeter least count. And if you look at those vernier calipers, these are digital. You know? Yeah, you get digital vernier calipers. Such a nice, na? You don't need to look at that vernier division, such a pain. You know? But fine, these are not available to you. You know? When you grow up, then your pain reduces. You go to research lab and you get digital calipers. Fine, okay. Second is least count of the instrument, right? So the general criteria is the choice of least count of a measuring instrument must be such that the uncertainty in the measured value is less than 1%. Don't worry, I will explain you the meaning of this sentence, right? So if you are measuring, say, maybe some length with a least count of 0.1 centimeter, this 1% tells you that delta L upon L, the relative error, what you call, right, is 1 by 100, 1%, 1 by 100, right? So if my least count is 0.1 centimeter, what should be the minimum length that I should be measuring? 1 by 100 equal to 0.1 upon, hey, simple maths, come on, 10, thank you, right? So 10 centimeter. So for every simple pendulum experiment, you at least start with 10 centimeter. You don't start with 5 centimeters. But there is some other problem at 10 centimeter. What is it? It oscillates very fast. You can't measure, right? So you start with 20 centimeter. That's the logic. But this is the idea of 1%. Is that clear? Right? So every measurement that you do, you should ensure that 1% uncertainty in the measurement is allowed. Why 1%? I will give you answer in some time, or maybe in the next session, right? Maybe post T. Okay. Time measurement. I asked you one question in the beginning, right? Why 20 oscillations? Over? Oh, but for a system which is behaving in a linear way, yeah. Yes, but I'm not going into machine now. Okay, we are actually talking only about humans, right? In that case, what should be number of oscillations that you should be taking? 10, 20. Why 10, 20? Yeah, okay. Okay, I keep you in a room where is like not much of air resistance. And not in a vacuum, but things are pretty cool enough. The amplitude is small, it's oscillating. Why 10 or 20? Is there any reason? Of course, there must be, right? Otherwise, this slide wouldn't be there. Okay, fine. So again, let's start with it. To keep the uncertainty of measuring device less than 1%, the choice of either the measured quantity or the measuring instrument must be such that the reading is at least 100 units of the least count. 1 by 100, delta L upon L, right? So the reading is 100 times your least count. Okay. I hope that part is clear, right? 1% wala? Yeah, good. So now, if the least count of the stopwatch that I used was 0.01 second, even your mobile has 0.01 second least count stopwatch, right? For this 1% idea, delta T by T is equal to 1 by 100, 0.01 upon 1, right? So one oscillation is sufficient. Why waste so much of time? 20 lena hai, 10 lena hai. Is this clear? This is clear, right? So with 0.01 second least count, okay, one oscillation is sufficient. Somebody was saying somewhere here. Okay, she's saying we will make mistakes. And this is something that somebody was saying. Okay. Is it possible to achieve repeatability in the readings using the watch with least count 0.01 seconds? T1, T2, T3. Do you get all of them to be same? If you decide to. एक बार लिया, दो बार लिख दिया. No? Yeah, but teachers are clever. No? They know it's very difficult to get. It is possible to get. If you really sit with a system for a longer time in the sense you do this multiple times. And then you program yourself to, okay, start, stop, start, stop. If you do it multiple times, you get used to that pattern. The moment you get that pattern, you can get T1, T2, T3 same, but it needs a lot of practice, right? And in that 2 or 3 hours of experiment, teachers know very well that you're doing it for the first time. You don't have time actually to, do this multiple times. So you are bound to get variation, right? If that is the case, then it's our inability to handle those stopwatches, right? Even if I have been given the best quality stopwatch in this world, 0.01 second least count, I cannot handle it. Why? Because I'm not sure whether I have started the stopwatch exactly at that point and I have stopped the stopwatch exactly at that time. That delay time comes in, right? That response time. You know what response time is? Sure? Everybody? How many of you don't know what a response time is? Relate to that analogy, like you feel sleepy in the class, so teacher throws a chalk to you. The action that is made and then the blinking of eyes, that's a response time. Same thing happens here, right? You're not sure that you have started and stopped the stopwatch exactly at the same point. It takes some time to register and then press that switch. Okay? If that is the case, let's restrict ourselves to 0.1 second. The first decimal place doesn't change. If it's 12.14, it might be 12.16, it might be 12.12, right? So that 0.1, the first decimal place doesn't change. We are not that bad, right? So if that is the case, then for 1% uncertainty, the minimum time that you need to measure is 10 seconds, right? 1 by 100, 0.1 upon 10, right? Now you go back to the apparatus and check how many oscillations that one needs to count to complete 10 seconds. It might be 12, make it 15. Okay, if it's 17, make it 20. If it's 6, make it 10. Why 10, 15, 20? They are nice numbers to remember while taking the data. And that tells you how many oscillations to take. Right? So this is not a God-given number that 20 is the thing that you have to take many times. When you go to maybe your third year, third year, you might come across an experiment called Cater's pendulum. Have you heard of it? No, so I will not get into that. But in that experiment, you have to take maybe 100 oscillations sometimes, right? We will discuss that maybe during the tea time or maybe after the session. Okay, I will show you certain graphs and then you will come to know why you need 100 oscillations in that case, right? Okay. I still have 21 minutes remaining and somebody was yawning. Okay. You need a break? How many of you need a break? 5 minutes? No? She just raised her hand and then she looked at. Okay. Just stand up. Stand up. Come on. Fast. Okay, sit down. Fresh? Good. Okay, that's a quick way of freshening up. Okay. And you feel like, oh, we are getting a break, but no, you are not getting it. Fine. Okay, so data collection, your favorite question to teachers. How many readings should I take? Every time you have been asking. I mean, even if you have, readings from the previous batch journal, you will still ask, kitna data le yaar, ek to kam karo usme se. Okay. So the simplest answer to this is, if it's a straight line graph, okay, how many points do you need to convince someone that it's a straight line graph? Don't tell me 1. Okay. Not even 2. Not even 3. I mean, 3, you have 2 points here, 1 point is here. I can also convince it's a curve. Generally 5, right? Worst comes to worst, 1 point line pe, baki ke 2 equally distributed on both the sides of the line. That's not how you plot a base fit line, right? So if you need 5 data points to convince someone that it's a straight line, then maybe 6 to 8 readings are adequate. Right? If it's a straight line graph, 6 to 8 readings are adequate, right? I mean, the extra reading just a waste of time and energy. But again, I'm telling you, you go back to your college, you are in the exam, there are 10 rows given there, don't try to show off in front of examiner. Don't do that. Just try to understand the requirement of the system and what is actually right. Right? So, understand what's right, that's all. Okay, fine. Okay, if it is non-linear, then the fun starts. Okay? If it's non-linear, then after covering the entire range uniformly, more readings are needed to locate the points of maxima or minima. Example. Now let me define 3 regions in this graph. Right? First region from here till here. Second region from here till here. And third region from there to bottom. Obviously, you will like to take more readings in the second. Why? Because you have to define that point of maxima quite well. The worst example, if I have only 2 points there, I can draw a peak like this, I can draw a peak like this, I can draw a peak like this, because I'm interested in the maximum value there, right? So for that, I need to have more readings there. Now you will ask me, how do I know that is the place where the maxima is going to occur? Obviously, nobody will know that. And that's why I told you that independent variable, you can vary in suitable steps. And by looking at the data, you can figure out, oh, there is some crowding of points happening. Then you can go back and take the data again. Right? Okay. Fine. Graph plotting. Why should we plot a graph? Very good. More than that, can you go one step ahead? Not just visualization of your data, the quality of your data. Yeah, right? Quality of your data. Right? Suppose you have a lot of scatter in your data. Right? And you plot a graph, you have an A4 size graph, right? You plot a graph in a very small corner of that graph paper. Will the scatter be visible? Nice, right? No, right? Exactly not. Okay, graphs are meant to show you the quality of the data. So you are supposed to stretch the graph as much as possible, right? Okay. So it shows the quality of your data. Then it is useful in eliminating systematic shifts in the data. We discussed that. Yeah. Graphs are useful in determining points of maxima or minima, and useful in determining relationship between two variables. Right? I'll just tell you how. Of course, I don't want to convince you which graph is better. Right? There is a lot of scatter there, not much scatter. So obviously, you come to know which graph is better. Right? Okay. Again, systematic shifts. Right? This is the graph that I showed you in the beginning. So you expect this kind of a graph, but suppose if there is a shift, every point will be shifted by equal amount, right? Slope won't change. Slope won't change. Right? Now this is quite good story as long as the systematic shift is in L. If the systematic shift is in some quantity which is raised to 2, you will be in trouble because that is going to change the slope of the graph. And that's why you have to be very careful. So in the next session, we will discuss those problems, right? What is to be done for that? Okay, so you should not force your graph to pass through straight line. Just follow the best fit. Right? Just follow the best fit. What will happen? Your intercept will change. So always try to prefer your answers from the slope. So after linearization, you try to get your desired quantity in the slope of that equation, right? Because if there is a systematic shift and you are not taking care of it, your intercept is going to change. Slope will not change. Okay. If you have a relation y equal to x raised to n, Stephen's law. You must have done Stephen's law in your college, right? Power is proportional to, P is proportional to t raised to 4. You are supposed to find 4, right? Okay. So same thing, y equal to x raised to n. Okay. So what you do is you take log on both sides, you plot log y versus log x, and the slope will give you the power. This is a popular way of getting relation between unknown variables that you have and related using this relation. Okay. Fine. How do we plot a best fit line? Very simple. There are some set of points, right? Is it a best fit line? No? No. Why? So they are not equally distributed, right? Okay, so the first criteria is equal number of points on both the sides of the line. Agree? Now, abhi to haan bolo, equal number of points, right? No. You need a break or what? Okay. I mean, equal number of points. I mean, yahan pe bhi 3 hai, wahan pe bhi 3 hai. What's the problem? There is nothing like that. It might happen then on a worse day, not a single point will lie on your line. But you can still get a best fit. Variance should be minimized, right? Have you heard this least square fit method, right? So the second criteria is distance of points on both the sides to be equal and minimum. You cannot calculate iska kitna hai, uska kitna hai. But you have to turn your scale in such a way that equal number of points on both the sides and distances are minimum, like they are balanced properly, right? So at least, so these are the two criteria, and you get reasonable. Now you can agree. I mean, that's fine. Not so bad. You can always tweak it a bit if you really want to, but this looks like equally distributed and distance is minimized. Do you know how to do that? How? Have you done this? Which experiment? Newton's law of cooling. It's like universal. Okay. How many of you have not done it? Raise your hands. Oh, there are many. Okay. Right. So you have a curve, right? And there is a point on the curve. This is not, I mean, fine. I mean, this is a pretty good method to do that, but one can even, go ahead with some mistakes in that. But that actually requires some practice. Okay. I'll just show you a video, maybe. I hope things work fine. Yeah. So there is a point A on the curve. So just rotate the mirror and see what happens. It's broken. Yeah. One side and the other side, right? Now it's obvious what you need to do. Make it look continuous. So arrange the position of the mirror in such a way that it looks continuous.
In the math school, they would say it's continuous in all
Ah.
orientations. But what you mean is it looks smooth or
It
different.
looks smooth, yeah.
Okay.
That's the normal now, right? Of course, one can stop at this point and then get the slope of this normal, and 1 by slope will be slope of the tangent, right? But if you still want to go ahead and you can still do the same exercise, keep the mirror on the line, right? Turn it, make it such a way that it looks straight, right? And of course, that line need not touch the tangent. Once the tangent to that point nearer, then even farther also it will be the tangent to that point, right? Is this clear? Right? I think you all must be having mirrors. You can even try it out. The only idea is you keep the mirror normal or perpendicular to the page, and things can be done. Let me just give you an example of some experiments. Okay, I still have 9 minutes. Okay, just hold on. Okay, is on the way. Black box experiments, right? So last year, girls did one black box, like magnetic black box. So you were there for the last year's volunteers, magnetic black box. Okay, did you get the answer? I don't know, right? I know. Okay, and I troubled you a lot in last year. Black box experiment is that kind of a experiment. Something is hidden in the box, and then you have to find out what's hidden in the box with the present knowledge that you have acquired over the years, right? So electrical black box. So you have a dabba, right? A plastic box with 3 sockets on top of the lid. Right? So there are certain electronic components which are connected inside, and students should find out the components and their values without opening the black box. Okay. This is the circuit that you will use, a variable supply here, right? External resistance to calculate the current. Okay, so you can measure the voltage across the resistor, and V by RE will give you the current flowing in the circuit. And then these are the 2 terminals across which you will connect AB, BA, BC, CB, AC, CA, because you do not know what's there, right? You will just try all your possibilities. Okay. Now I'm telling you the answer right now. Right? I will tell you the answer. You have to tell me the graphs. Okay. This is the circuit, right? Between A and B, you have a diode, and B and C, it's a 1 kilo ohm resistor. And across A and C, there is nothing. Right? It's open there. Is this clear? Right? Okay. And I think you all know banana sockets and soldering and all. Right? So like this diode is soldered on both these points. Resistor is soldered at both these points. Okay. You know how to solder things and do all this. Right? Great. So these are the 3 combinations which I have connected, A, B, right? So let me show you the circuit again. So connect A here, B here, then B here, C here, and A here and C here. Is that clear? Yeah. Okay, fine. So AB, right? BC, resistor, clear? And AC, there is nothing. It's open, right? So flat. It's a flat line. Yes, no. I know it's a tea break, but thoda sa push karo. Will it be a flat line? Will the current see nothing there? What will it see? You are nodding your head for both. Yeah, but then is it something that current will see? Don't you think current will also see this diode and the resistor? Right? So I should be getting something like this. Okay, a diode in series with a resistor. Right? It's just you who saw that कि हाँ A and C के बीच में there is nothing connected. Right? But why will current see that? Current will pass through a diode, because I showed you, right? That's why I went back and showed you that now in that case also your diode is going to be in forward bias condition. Right? Now you would wonder, this graph is not same as this graph. Or maybe this graph, this straight line part is fallen a bit. What is that? Why is that happening? Resistor value. A typical resistance value in this region is around 8 to 10 ohms. And that's why I have, purposely chosen a resistor value of 1 kilo ohms. So you get appreciable change in the slope. Slope has decreased. That means what? Resistance has increased. Because slope is what? I by V. So by getting that, slope of that line, I'll get the slope of that resistor connected in series. That's a black box, right? It was not something like you did not know at all, right? You knew resistance, IV characteristics, you know the diode IV characteristics. Now you just have to get that data, plot it, religiously, and then interpret from that data. That is the whole idea of black box, right? Pretty challenging. Those who love experiments should really take up this. There is another type of black box. You have 2 sockets here, 2 sockets here, right? Across these 2 sockets, I have a pencil cell, a AA battery pencil cell. Across this, I have a capacitor, both of the same value, 1.5, 1.5 volts. How will you tell me which is cell and which is capacitor? Is the question clear? There is a pencil cell and there is a capacitor charged to 1.5 volts. Yes? Okay. Or in other words, you can just take a wire, short karo isko, then short this, and again measure the voltage. Here you will still get 1.5, here you will not get anything. 0. That will tell you which is the capacitor and which is your cell. Right? And then you can obviously use your AC response and everything to get the value of the capacitor. That's a further work that you can do, right? But then this kind of a black box can come in different formats, different shapes, right? You can have a delta function, you can have a star function, you can have 4 terminal black boxes, n number of things. You can have capacitor, inductor, resistor, anything, right? The torture never stops, right? So, fine. Anyway, this is my next session, which I will stop now. It's 3 minutes. We can have a break. Okay, everybody. Okay. So tired?
Everyone, when
Yeah.
you want them back?
3:30. I mean, that's their legitimate hakka hai wo, आधा घंटा, so no issue. Okay? But come at least 5 minutes before so that we can start exactly at 3:30.